Hi. In this lecture, we will see the tuple data type in Python. In the last two lectures, we have seen the string data type and the list data type. So let's revise the list data type. Lists were a heterogeneous collection of items. A single list can contain different types of elements, and the main property was lists were mutable. Okay. So once created, the same list at the same memory location, which means in place, you can change the elements of a list. So tuples differ from the list in that one way. Rest all things are same. Again, it is an ordered sequence of items, and it can be a heterogeneous collection as well. The only thing is a tuple is immutable. So once created, the elements of tuple cannot be changed. So let's see what tuples are and how to use them in Python. Firstly, what are tuples? A tuple is a built-in data type in Python that stores a collection of items. Okay, it will store a collection of items. Again, nothing is given, so heterogeneous collection is possible, which means a single tuple can contain different data type of elements as well. So the characteristics of tuple are, it is also ordered. Just like list, tuple is also ordered, which means elements are stored in a definite sequence, and you can say that this element is the first element, this element is the second element, and so on. So every element can be accessed using its position or the index. Second is immutable. So this is very important. Tuples are immutable. This is the only difference between a tuple and a list. So once created, it cannot be changed, unlike list. So list once created can be changed, but tuples cannot be changed. Third is heterogeneous. So they can contain different data types in the same tuple. A single tuple can contain an integer, a floating point number, a complex number, a string, a list, or a tuple. Like any data type is possible. So a single tuple can contain different type of elements. That is possible. So it is heterogeneous. In Python, generally all collections are heterogeneous only. And that makes it different from other programming languages like C++ and Java. Okay, their arrays are homogeneous. Okay, finally indexed. Since it is a sequence, since there is an order, you have indices as well, just like strings and lists. A tuple will also have positive and negative indices. Same way we can access elements of a tuple or even slicing. So accessing elements and slicing will work the same way as list in tuple as well. So elements can be accessed by the position or index which starts from 0. Okay. Now let's see how can we create tuples in Python. To create tuple, we use round brackets. To create list, we used square brackets. To create tuples, the same way, but we will use round brackets. Okay. So if you just write any number of elements inside round brackets, let's say 1, 2, 3, this will be a tuple. And similarly, we created list using square brackets like this. This is a list. Okay. So if you have to create an empty tuple, in the round brackets, you don't write anything. So this will be an empty tuple. So if you initialize a variable empty with an empty tuple, and if you print empty now, you will get the empty tuple printed as the output. If you print the length of this empty variable, you will see length will be 0, which means there are 0 elements inside this tuple. So like different things, if you print the type of empty, if you print the type of empty, you will get answer as class tuple, because this belongs to the tuple class, which means the data type is tuple. And if you print the length of empty, you will see the number of elements is 0. Okay, so this is how you can create an empty tuple. And if you have to create a tuple with a single element, you can write it like this. So inside the tuple, let's say I write a single element 5, but I have to write a comma at the end. If you are trying to create a tuple with a single element, only with single element, this is the case. If you have more elements, then you don't need a comma at the end. For example, if you have 3 elements, you don't need a comma at the end. If you write a comma, that's okay. But even if you skip the comma, that's okay. But if you have to create a tuple with a single element inside it, you have to end it with a comma. The reason is, if I just write it like this, so this will become an arithmetic operation, like, right? Because we have round brackets and 5 inside it. So like here, round brackets will not be treated as a tuple. If you just write a single element inside it, this will just be considered as the number 5. So this will be considered as normal brackets. And that is why if you want to create a tuple with a single element, you have to end it with a comma so that the compiler can know that this is actually a tuple containing a single element. So it's a very important point. In Python, if you want to create a tuple with single element or just one element, you have to end it with a comma. This comma is necessary. If you don't write comma at the end, the type will be different. So here what will happen? If you print the type of T, you will get the tuple class tuple, right? And it will contain a single element 5. But if you create a variable like this, let's say T is equal to 5, then here if you print the type of T, the type of T will be just integer, int. So the brackets will be ignored and just the value 5 will be stored in T. So it will try to evaluate this expression, and this expression will evaluate to 5 only because brackets will go away. And that is why you need to add a comma at the end. So very important point, if you have just a single element, always end it with a comma. And if you have multiple elements, let's say you want to create a tuple with same type of elements, 10, 20, 30, here you don't need to end with a comma. Since you have 3 elements, this will create a tuple with length 3 and it will assign in the variable T. And tuple can have heterogeneous elements as well, which means a single tuple can have different data types. So here we can see like first element is an integer, second element is a string, third element is a floating point number, and fourth element is a boolean, okay, true. So this is also possible, and like you can have different data type elements present in the same tuple. Here this tuple will have a length of 4 elements are there. This tuple has a length of 3, it has 3 elements. And also tuples can contain duplicate items as well. So you can have like a tuple containing 1, 1, 1, 2, 2 and 3 like this. It can have duplicate elements, same element can be present multiple times. So here the length of this tuple T will be 1, 2, 3, 4, 5, 6 elements. Okay, same with list as well. List also can contain duplicate elements. You can create a list like this. Okay, and here the length of this list will also be 6 elements. So strings, list and tuples are collection which can have duplicate elements as well. Now other way of creating tuples is using the tuple constructor. Since tuple is a class, tuple will be a constructor. For now we can just understand that tuple is a function. So using the tuple method, you can create a tuple in Python. So the syntax is you just write tuple and in the brackets you just give an iterable. Any iterable will be converted into a tuple. The same syntax we have seen for list as well. List and inside the brackets we can give an iterable, right? So the same syntax is there here as well. So Python provides a built-in function tuple that creates a new tuple from an iterable. So the iterable, whatever values iterable will have, that will be converted into a tuple. And if no argument is provided, it returns an empty tuple. So if you just write tuple and if you don't provide any iterable inside it, then it will just give you an empty tuple. So when you print the empty variable here, you will just get output the empty tuple here, okay? So this is how you can create tuples using the tuple constructor. Now what if we are actually giving it an iterable? So here the string S is GATE. String is S contains GATE, these characters. And we know that string is an iterable. So what will happen? If I write tuple of S, it will convert this iterable into its values and it will create a tuple out of it. And string as an iterable gives what values? Its characters one by one, right? So here we will be creating a tuple containing the string G, then the string A, then the string T and the string E. So it will have 4 elements. First element is G, second is A, third is T and fourth is E. So this is how you can create tuples. And the same way was for list as well. List also had a constructor called list. Tuple also has a constructor called tuple. So string is an iterable, you can use this, and if you're assigning it to the variable chars, so chars will be a tuple now, and when you print chars, the output will be the tuple containing values GATE. Similarly, range function, we know range function is also an iterable, so you can use the range function as well. So here we are given range 1, 5. Range 1, 5 means what? 1 is the starting point, 5 is the stopping point, and step size is not given means default step size is taken as 1, which means left to right traversal, and start point is inclusive, so we will start at 1 and then we will stop at 4. Stopping point is exclusive, it is not included. So range 1 to 5 will take these values, and if you convert it into a tuple, range is also an iterable, you can convert any iterable into a tuple using the method. So this will give you the tuple containing values 1, 2, 3 and 4. Okay. So just like list, here also same thing applies. So if you want to convert a range into a tuple, you can do that and you will get the output as a tuple containing values 1, 2, 3, 4. So this is how you can create tuples in Python using the round brackets or using the tuple constructor. Okay, now let's see accessing elements. So accessing elements using indices and slicing, we have seen in detail in string lecture and in list. So if you want to watch that, you can watch the string lecture. There we have covered it in detail. Here the same concepts will apply. Indexing is same for any collection, which means string, list and tuple. Indexing and slicing is exactly same. So indexing in Python allows us to access individual elements of a tuple using their position or index. And positive indices start from 0 and goes up to the length of tuple -1, which is left to right traversal. And negative indices start from -1 and goes backwards till minus of length of tuple, and it is right to left traversal. So if you have a tuple containing elements 10, 20, 30, 40, then the indices for these elements will be 0, 1, 2, 3. Positive index starts from 0. Python is a zero index programming language. So first element will have an index of 0. So and length of this tuple is what? The number of elements is 4. So length is 4. So positive indices go from 0 to length -1, and negative indices start backwards from right, which is -1 and -2, -3 and -4. So it goes from -1 till minus of length of the tuple. So this is what the positive and negative indices for any tuple are. So any element can be accessed using the positive index or the negative index, whatever you want. Both indices are valid. So let's see accessing here. So if a tuple contains 4 elements, 10, 20, 30, 40, then the positive indices will be 0, 1, 2, 3. Negative indices will be -1, -2, -3 and -4. And if you print t of 0, t of 0 will be what? The 0th element, which is 10. And t of 1 means the first element, which is 20. T of -1 means the last element, which is 40. And t of -2 means the second last element, which is 30. So you will get elements 10, 20, 30, 40 and 30. Okay, so you can access any element using their index. And if you go out of bounds, which means if you just write t of -5, then t of -5 does not exist. So you cannot index this element, you will get an error. The program will stop. So always be mindful, use the index which already exists. If you go out of bounds, you will get an error. And similarly, if you write t of 4, this index does not exist. Here also you will get an error. The index is out of bounds. Okay. So only the indices which are valid, either be positive or negative, that can be accessed. And tuples are immutable. So tuples cannot be modified once created, just like strings. Strings may be like once the string is created, they cannot be modified. So in place at the same memory location, you cannot change an element of a tuple. In list we can do that, but in tuple we cannot do that. So we cannot do assignment at a particular index like this. So if we have created a tuple in memory like 1, 2, 3. 1, 2, 3. So in memory this will be stored. Variable t will be pointing in memory to a tuple containing elements 1, 2 and 3. This will be a tuple. Okay. And let's say it's at memory location 756. So the variable t will be pointing here. Now when you say t of 0 is equal to 10, so we can access and see the element. You can print the element. That is okay. And you can even assign it into some other variable. That is also okay. But you cannot change it. So we cannot do item assignment. So if you say t of 0 is equal to 10, this will give you error. Because what you are trying to do here is you are trying to assign the value 10 to the 0th element. Which is like you want to change this element to 10. That cannot happen. A tuple is immutable. You cannot change the elements at the same memory location. Once created, it will remain forever. You can create a copy of it. You can create another tuple, but at the same memory location, you cannot change it. So this is invalid for a tuple. So if you do this, you will get a type error. Tuple object does not support item assignment. The same type of error we have seen in strings as well. String may be like we cannot assign an element at a particular location to a string. Once created, it is immutable. Okay. But there is a catch here. So tuples cannot be modified once created. However, if the tuple contains a mutable object, if the tuple inside it contains a mutable object, which means let's say there is a list inside a tuple, then that object can be modified. So for example, what we are doing here, we are creating a tuple in which the first element is a list containing elements 1 and 2 and the second element is 3. So this tuple contains how many elements? 2 elements. This is at index 0, this is at index 1, right? Even though you are seeing 2 commas, but still the elements are 2 only, right? The first element is a list itself and the second element is an integer. So we already know how memory management happens if you have a list inside a tuple or a tuple inside a tuple. What happens is, like, since the first element is a list, this list will be independently stored somewhere else. Let's say it is at memory location 756. Now when you are creating the tuple, the first element is this list. So the tuple t will be, let's say, at present at memory location 819. Then the variable t will be pointing here. And the first element is nothing but, it is a pointer to this memory location. The first element is nothing but a pointer to this memory location. Again, this concept we have covered in list lecture. If you are creating list inside a list, how is the memory managed? Okay. So it will create the list at some other memory location and it will just store the pointer as the first index inside the tuple. Now the second element is the integer 3. So integer 3 will be present as it is. Now if you want to change t of 0. So if I say t of 0 dot append 4, let's say, if I just run this command, t of 0 dot append 4. What does this mean? Although tuple is immutable, tuple cannot change, but t of 0 is a list. T of 0 is a list. This is a list and this is a tuple. The compiler knows the data type as well. This is a tuple and this is a list. And lists are mutable. So at this memory location, I can make changes. At this memory location, since list can be mutable, you can add elements, you can remove elements, you can change elements, you can do anything. So any list operation will work. I can say append, extend, or even pop, remove, anything, okay? And that will work because this is a list. And here you can append 4. So 4 will be appended to this list. But you cannot make changes to this memory location because this is a tuple. So you cannot make changes to t of 1. T of 1, let's say you are now saying it is a string hello. T of 1 was what? T of 1 was an integer. This is hardly coupled. Since this is a tuple, it is immutable. This element cannot change. So this will give you an error. But this is okay because t of 0 was a list and you can append here. So if you have a mutable object inside a tuple, that can be changed. Okay. So this is allowed. So t of 0 dot append 4 is allowed. And when you print the tuple now, the first element is this list. So 1 to 4, the list 1 to 4 will be the first element now. And the second element, which is at index 1, will be 3. So this is what you will get. Okay. So if the tuple contains a mutable object like a list, the object can be modified. Only the mutable object can be modified, tuple cannot be. And even if you have a tuple inside of a tuple, that cannot be modified because tuples cannot be modified, right? So in the same example, if you had, this was a tuple, let's say. If you had tuple containing 1, 2. Now this tuple is immutable. So here in memory, what will happen? This 1, 2 will not be a list. Instead of that, it will be a tuple like this. It will be a tuple. Okay. So now this is how it will be pointing. Now if you run t0.append4, t of 0 is a tuple and it cannot be modified. Actually, there is no append function for a tuple as well. There is no append function present for tuples because you cannot append elements to a tuple. Like tuple cannot be changed. So this will also give you an error. Only mutable objects inside a tuple can be modified. Okay. Now the next concept is slicing. Again, slicing is covered in detail in string lecture. Same slicing process will be applicable for tuples as well. You can create a slice out of a tuple, okay? And that will create a copy of a tuple, which means a new tuple will be created. Original tuple will not be changed. So slicing is the process of extracting a portion of a sequence. So you can do it using sequence, start, stop, and step. And sequence can be any sequence like a string or a list or a tuple. And there are two syntaxes to it. You can either give start and stop. If you are just using 1 colon, then you are only giving the values of start and stop. And if you are using 2 colons, you are giving the values of start, stop, and step. Now what are start, stop, and step? Start is the index to begin slicing from. It is inclusive and default is 0. Stop is the index to stop slicing at. It is exclusive, it is not included, and it defaults to the length of the sequence. And step size is optional because you can skip it as well in this. And it is the step size, like how many elements we want to skip before going to the next element, okay? So if its default value is 1, which means we are taking all the elements, okay? So this is what start, stop and step are. Now let's look at an example. So here we have a tuple 0, 1, 2, 3, 4, 5. So the tuple is 0, 1, 2, 3, 4 and 5. So the positive indices, so the length of this tuple is what? How many elements are there? 1, 2, 3, 4, 5, 6. 6 elements are there. So length is 6 and the positive indices will be 0, 1, 2, 3, 4, 5. These will be the positive indices and the negative indices will be -1, -2, -3, -4, -5 and -6. These are positive and negative indices. Now if I do a slicing from 1 to 4, if I do a slicing from 1 to 4, here the 1 is the start value, 4 is the stop value and step size is not given, so default step size will be taken as 1, and if step size is positive you are doing left to right traversal. So start point is 1, which means this point, and stopping point is 4, and 4 is exclusive, 4 is not included, so we'll stop at 3. So this is the slice that we are taking. So slicing always gives you a new tuple. It does not change the original tuple. Original tuple will be stored in memory at some other memory location, and when you do slicing, another tuple will be created at some other memory location and that will be returned. Okay, so another tuple will be created containing the values 1, 2, 3, like from 1 to 3. So 1, 2, 3 values will be there. The values will be 1, 2 and 3. Another tuple will be created, okay? So the output will be 1, 2, 3. Similarly, if you do t:3, if you do t:3, so here also step size is not given, so default step size 1 will be taken. Start is also not given, so start default value is 0 and stop is given as 3. So what all we will take? We will go from 0 to 2 because 3 is not included. So 0, 1, 2 elements will be given. So another tuple will be created containing the values 0, 1 and 2. So this will be the output. If you are slicing a string, you will get a string. If you are slicing a list, you will get a list. And if you are slicing a tuple, you will get a tuple. Okay. Now we have : -1. This is the standard way of reversing a string or a list, and this is also the standard way of reversing a tuple. You will get a new tuple which is the reversed of the original tuple. So let us see how it works. If you have : -1, so here we are using 2 colons, which means we are giving start, stop and step, all 3 of them. Step size is given as -1 and step is negative, which means we will do right to left traversal. And start is not given, so start default value is 0. Stop is not given, so default value of stop is length of the sequence, which is 6. So we will take all elements from 0 to 5. Stopping point is exclusive, and we will travel backwards right to left, and -1 means we will take every element. Okay, so the answer will be another tuple containing the elements 5, 4, 3, 2, 1 and then 0. So this is the tuple that you will get in output. So the output will be the reverse tuple. Okay, so this will be the output. Now next is t -2 to -1. Now slicing works the same way for negative indices as well. -2 to -1. So here the starting point is -2, the stopping point is -1, and step size is not given, so step size by default will be taken as 1. Now you are starting at -2, which means you are doing left to right traversal. So you are doing from -2 to -1. Now -1 is exclusive, so we will stop at -2 itself. -1 is exclusive, so we will stop at -2 itself. So we are only taking a single element 4. So the output will be a single tuple containing the element 4. Now whenever you are writing a single tuple, you will add a comma at the end, right? So even in the output you will see tuple like this, single tuple containing an element 4, and you will see a comma at the end of it. So every tuple with a single element will have a comma at the end. So the output will be a tuple containing a single element 4 like this. Okay, so this is how you can do slicing in tuples. And now let's see how we can loop through tuples. So all the concepts are exactly same as list. Okay, we have covered this in detail again in list. Exactly same way you can use a for loop to iterate over a tuple. We can use a while loop to iterate over a tuple. But since tuple is an iterator, using a for loop is beneficial because for loops are created if you want to iterate over an iterable, and tuples are iterables. Tuples are iterable. You can iterate over all the elements of tuple one by one, and there is order as well. So you can do that. You can use a for loop to iterate over a tuple, and all the elements will be given one by one. Okay, and we can use the while loop as well, and we can use the enumerate function as well if you want the index and element both. So if we write for item in 1, 2, 3, firstly item will take the value 1, 1 will be printed. Then item will take the value 2, 2 will be printed. Then item will take the value 3, 3 will be printed. So this is how you can simply iterate over a tuple using for loop. Now if you want to iterate using a while loop, that is slightly complicated, right? Because while loop works on conditions and for loop works on iterables, and tuples are iterables. So using for loop is easier. But if you want to use a while loop, you will have to take a counter, which is the index. So firstly I will check index number 0, then index number 1, and then index number 2. So here I will take value 0 and the length of the tuple is 3. So since 0 is less than 3, we will go inside, we will print t of 0. T of 0 is 5, 5 will be printed. Then I will be incremented by 1. Then again 1 is less than 3, so t of 1 will be printed, which is 10. Then again I will be incremented by 1. Then again 2 is less than 3, so t of 2 will be printed, which is 15. And again I will be incremented by 1. Now 3 is not less than 3, so we will come out. And this is how, using a while loop, we can traverse or iterate over an entire tuple. And if you want indexes and values both, we know there is an enumerate function. Enumerate function always gives a pair. Enumerate function always gives a pair. So till now in string and list we have seen that enumerate function gives a pair. In this lecture we will understand what pair means. Pair is internally a tuple only. Okay, so when we see packing and unpacking of tuples in the same lecture, there we will see actually enumerate function always returns a tuple. Okay, we will understand that, and I will come back to this concept. Okay, for now what do we know? Enumerate function gives a pair of index comma value like that. So if you pass any iterable inside enumerate function, it will give all its values one by one, but along with the values it will give the index as well. So you will see values as 0 and element as a, then value index as 1 and element as b. And you can take it in two variables. So this, let's say I am taking in the variable idx, and the other like the value I am taking in the variable val. So index will take value 0 and val will take string a, and then index will take value 1 and value will take the value string b. So when you print them, 0a and 1b will be printed. So that is how you can use the enumerate function if we want the index and the value both inside the for loop. Now let's see mathematical operations on tuples. So if you use the addition operator between two tuples or multiplication operator, what happens? So this works exactly the same like in strings or lists. So if I add two tuples can be added in Python, and if you use the addition operator between two tuples, both the tuples, like the second tuple will be added at the end of the first tuple. So all the elements will be combined. So this is also called concatenation. This operation is called concatenation. So we are concatenating the second tuple at the end of the first tuple. So if you do 1, 2 plus 3, 4, there are two tuples. Then a single tuple will be formed. Firstly, it will contain the elements of the first tuple, and then it will contain the elements of the second tuple. So if the first tuple contains L1 elements, second tuple contains L2 elements, then after the addition operator, the final tuple will contain L1 plus L2 elements. Next we have repetition. So you can multiply a tuple with an integer. We can multiply a tuple with an integer. We cannot multiply a tuple with a floating point number or another tuple. Okay, only with an integer. So if you multiply a tuple with an integer, the same elements will be repeated those many times. So if you do 1, 2 into 3, the output will be a tuple containing 1, 2, 1, 2, 1, 2 like this. So if the original tuple contains L1 elements, and if you multiply it by number a, the final tuple will contain L1 into a elements. Okay, in the same order the elements will be present those many times. So if you create a tuple with a single element like this, 0, into 3 you will get 0, 0, 0. Remember that if you do it this way, again if you forget the comma, this will give you the output as 0 only, because this is integer 0 into 3, which is 0. But if you do 0, into 3, this is a tuple containing a single element. And if you do into 3, you will get 0, 0, 0 3 times. Now we have membership operator in and not in. That is very simple. It will just check that the element is present in the tuple or not. If it is present, you will get true, otherwise you will get false. Okay, and then we have length. You can calculate the length of any tuple, which means the number of elements present inside the tuple, and you will get it using the length function or len function in Python. The same function works for strings and lists as well. Now these functions we have seen for list, min, max and sum. You can calculate the minimum element, maximum element, or the sum of all elements in a list. Same way you can do it for a tuple as well. The same function will work for tuples as well. The min function gives you the minimum element, the max function gives you the maximum element, and the sum function gives you the sum of all the elements present inside the tuple. Okay? And if you do comparison of any sort, then it will do the lexicographical comparison just like strings. This will work for list or tuple as well. Okay? So the same lexicographical comparison actually is done on list or tuple. So if you do 1, 2 is less than 3, 4. So firstly, it will compare the first element. If the first element is smaller, it will give you true. But if the first element is let's say 0, 2, here the first element is 1, here the first element is 0. So 1 is not less than 0, so it will give false. And if the first element is actually equal, let's say you have something like this. If the first element is equal, then it will compare the second element. So 2 is less than 3, so it will give you true. Okay, so lexicographical comparison, just like strings, it will compare the first element. If they are equal, it will compare the second element, and so on. Okay, so that's what happens. 1, 2 will be less than 1, 3 because 1 is equal, so it will compare the second element. 2 is less than 3, so it will give you true. Okay, same will happen for less than equal to, greater than equal to, or greater than operator as well. Okay, it is just lexicographical comparison. This concept we have seen in detail in strings. Now next, if you want to search an element, see again now in list we had methods like append, insert, extend, and we had pop and remove. So they were all used in a list to add or remove elements in place, and lists are mutable. List in Python is mutable. So you can have methods like these for list, but for tuples none of these methods are present because tuples are immutable. So you cannot do in place append or insert or extend or pop or remove. None of these are present because they are all related to mutability. In place they work, and in the same list you can add elements or delete elements, right? And in tuples, since tuples are immutable, these functions or these methods are not present. So, but what we can do is, in tuples still we can find elements. So searching and counting methods are same. The index function which was there in list is available for tuple as well, because that is just to search an element at which index that particular element is present. So that can still work. So index function, if you work use with any element, it will search for that particular element and it returns the index of the first occurrence of that particular value x. So if you have a tuple containing values 10, 20, 30, the indices will be 0, 1 and 2. And if you do t.index 20, it will just give you the first occurrence where the first time 20 is present. So 20 is present at index 1, so 1 will be given as the answer. And if the same element is present multiple times, then also it will work. So let's say a tuple contains 1, 1, 2, 1, 2, 3 like this. And if you do to t.index 2, although 2 is present here also and here also, it will just give you the first occurrence, which means 0, 1, 2, 3, 4, 5. So the first occurrence is at index 2, so 2 will be given. And also notice that an element can be anything. So if you have a tuple like this, let's say a tuple containing 1, 2 and then 1 and 2. So here the first element at 0th index is a tuple containing the elements 1 and 2. The second element is at index 1, which is integer 1, and the third element is at index 2, which is integer 2. So here the first element is itself a tuple. So if you do t.index of 2, so 2 is not present at index 0. At index 0 we have a tuple containing 1 and 2. So don't make this mistake. 2 is present at the first time at index 2. So 2 will be given as the output. And if you do t.index tuple containing 1 and 2, then this element as it is present at index 0, so you will get index 0. So an element can be itself a list or a tuple or a dictionary as well. So be mindful and work accordingly, okay? Index function will search for the exact same element. This element is present inside the tuple which is present at index 0, but it is not equal to the element at index 0. So it will move forward and search, okay? So this is how the index method works. And if you are searching for an element which is not present inside the tuple, then it will give you an error. Always be mindful. Whatever value you are providing in the index function should be present in the tuple. If it is not present, the index function will raise an error, the program will stop. You will get value error, tuple.index x not in tuple. A very obvious error will be given. You are trying to find an element x which is not in the tuple. So if you want to create error-free code, you have to wrap it inside a if loop, if condition, So you should write it like this: if x in tuple, then only you try to search the index of x in the tuple. So tuple means, let's say the variable is t. Then you should do t dot index x like this. So if the element x is not present inside the tuple t, then the membership operator anyway will give you false and you will not go inside. So error will not be there. So always wrap the index function inside a if condition so that you will not get an error. Okay. So this is how the index function works. And if you have to count how many times an element x is present, then we have count function. Both these functions were there for list as well. So it counts how many times x appears in the tuple. So if you have tuple as 10, 20, 30, and if you count how many times 20 is present, it is present one time, so the answer will be 1. And if you count how many times 40 is present, if an element is not present, here you will not get error. Count function does not give you an error if the element is not present. Count function will just give you the count as 0. Okay. So this is how it works. The count function and the index function, they are used for searching and counting elements inside a tuple. Now if you want to sort a tuple, again the dot sort function, we had dot sort function for a list, and for a list we had a dot reverse function. So reverse and sort function were used to sort a list and reverse a list in place. So they are again not available for tuples. They are not available for tuples because they are doing sorting and reversing in place. So if you have to do sorting and reversing out of place, in list we saw a function called sorted. That gives you a new list, right? It produces a new list. And similarly, if you have to reverse a list out of place, which means not at the same memory location, if you want to preserve the original list as well, we have seen we can use slicing. So these two are in place, which means at the same memory location this happens, or the same list is modified and the original list is modified, it is not present now. But if you want to sort a list out of place, which means a new list is created, or if you want to reverse a list in which you want to create a new list, then you can use the sorted function or the list slicing. Then these concepts are available for tuples as well. They will work for tuples as well, tuples or strings. So for immutable data types, you can only do out of place sorting or reversing. You can never do in place sorting or reversing. So for strings and tuples, this doesn't work. Strings and tuples, this doesn't work. For strings and tuples, sorted function and the slicing works, and it will create a new copy, which means a new string or a new tuple will be created. Okay. So if you want to sort a tuple, you can use the sorted function. It returns a new sorted list. And remember always that sorted function always returns a list. Even if you're providing it a tuple, the answer at the end will be a list. Okay. So if you want to create a tuple at the end, you have to use the list and you have to use the tuple constructor to convert the list into a tuple. So what happens is, let's say you have a variable nums and it contains a tuple containing 4, 2 and 7. And if you do nums2 is equal to sorted of nums. So you passed a tuple inside it, but nums2, the type of nums2 will be a list containing the elements 2, 4 and 7. So list will be given as output. Sorted function always returns a new sorted list. Okay, even if you're passing a tuple. If you want nums2 to be a tuple, you can do it this way. You can just wrap this entire thing around that tuple constructor. So you can write nums2 is equal to tuple of sorted of nums. So now tuple sorted of nums will give you a list, and list is an iterable. So the tuple function will convert the iterable into a tuple, and then the output will be tuple 2, 4, 7. Okay. So this is how the sorted function works. And if you want to sort in reverse order, you can use the sorted function and pass the argument reverse is equal to true. It will sort it in reverse order, which means descending order. So the list will be 7, 4, 2 now. So this is how you can sort a tuple using the sorted function. Now let's look at the concept of tuple packing. So what is tuple packing? We can assign multiple values to a variable without parenthesis. So in Python, we are allowed to create a tuple without using parenthesis as well. So if I write a is equal to 1, 2, then even without writing the round brackets, it will automatically consider this as a tuple. It will create a tuple, and variable a will now contain a tuple containing values 1 and 2. So if you just write this line and if you print a, then the tuple containing values 1, 2 will be printed. So you can skip writing parentheses if you have more than one elements, because if you have one element, this will not work. If you just write a is equal to 1, this will be the integer 1 assigned to a. But if you write a equal to 1, 2, then the tuple 1, 2 will be assigned to a. Automatically it will add brackets. Okay, so this is called tuple packing. You can skip writing parentheses and still like the values will be packed in a tuple and stored in the variable. Okay. So if I write t is equal to 1, 2, 3, it is a valid way of creating a tuple. We don't need to write parentheses. Automatically a tuple will be created and it will be assigned in the variable t. This is called tuple packing. When you print t, the tuple 1, 2, 3 will be printed, and when you print the type of t, class tuple will be given. And again, the order of the values will remain same as the order which we are giving values. Okay, because tuple is an ordered sequence. The first value that we are giving will be index 0, then index 1 and index 2 and so on. So this is the concept of tuple packing. Parentheses are optional when packing. You can write the parentheses as well. This is also a valid way of creating a tuple. This we have already seen. But if you skip the parentheses, then also it is okay. So why is tuple packing useful? The more important concept is tuple unpacking. Unpacking means assigning each element of a tuple to a separate variable. So this also is allowed. So in Python, I can write a, b, c is equal to 10, 20, 30. So here what happens? Let us say if I write a, b, c is equal to 10, 20, 30. Let's say here also I skip brackets on both sides. So this is valid. So internally what will happen? This will be packed as a tuple. Since we skipped the brackets, that is okay. It is okay to skip brackets. Internally compiler will think that this is a tuple. Tuple containing values 10, 20, 30. And you are trying to assign this tuple to a triplet of variables. You are assigning it in 3 variables, a, b, c. So internally this also will be considered as a tuple containing the variables a, b, c. And when you are doing the assignment, this tuple will unpack. This tuple will unpack and each of the variables will hold the values now 10. This variable will hold the value 20. And this variable will hold the value 30. So this is called tuple unpacking. You can unpack a tuple as well, so which means you can assign a tuple to multiple variables at once. Okay, and it's a special feature, right? Like you can skip brackets to create tuples and you can assign multiple values to multiple variables at once in a single line, like this. Okay. So if I write a, b, c is equal to 10, 20, 30, a will take the value 10, b will take the value 20 and c will take the value 30. And it is happening because of tuple packing and unpacking. This is the feature of tuple. Internally, they are taken as tuples. So when you print A, 10 will be printed. When you print B, 20 will be printed. And when you print C, 30 will be printed. So Python matches the left side is equal to right side elements. So it will automatically match the left side variables with the right side elements and it will assign the values. But note that the number of variables should be equal to the number of elements. You cannot have more variables. So you cannot write A, B, C, D is equal to 10, 20, 30. This is wrong. Because this tuple cannot be assigned to this tuple. Here we have more variables than elements. So this unpacking is not allowed. Even you cannot write A, B is equal to 10, 20, 30. This is also wrong. Because here you have more elements and less number of variables. So this type of unpacking is illegal and this type of unpacking is also illegal. The number of variables should be exactly equal to the number of elements. Then only tuple packing and unpacking can happen. Okay. So now let's see mismatched unpacking. So if you have less number of variables or more number of variables than the number of elements, then it is called mismatched unpacking and you will get error in such cases. So if you say t is equal to tuple 1, 2, this is allowed, right? Because you are assigning the entire tuple in the variable t. But if you say a, b, c is equal to t, so here what is happening? You are essentially writing a, b, c is equal to tuple 1, 2. So you cannot unpack this tuple in 2 variables. That is not allowed. So you will get value error, not enough values to unpack. Okay, there are only 2 values and you have 3 variables. So you are getting error, not enough values to unpack. And if you have less number of variables, then also this will happen. Okay, so Python again matches left side to the right side of elements and variables must match the element count. The number of elements should be exactly equal to the number of variables, then only unpacking can happen. Now there is an extended tuple unpacking concept which is introduced in Python 3+. So in the latest versions of Python, this concept is there. You can use the star operator And how does it work? Let's see. So if you write a comma star comma a comma star b comma c is equal to 1 comma 2 comma 3 comma 4 comma 5, which means you have less number of variables and you have more number of elements. Then whatever variable you are adding star with, that will consume all the remaining elements. So here what will happen? A will be assigned the value 1 and C is present at the last. So C will be assigned the value 5. And whatever values are left in between 2, 3, 4, they will be assigned as a list inside the variable B. So A will be element 1, C will be element 5 and B will be the list containing the elements 2, 3, 4. Okay. Similarly, let's say if you write A comma star B is equal to 1 comma 2 comma 3. Then in this case, A will have the value 1 and B will take all the remaining values in a list. So this is what you can do. Star is the operator which you can use to do that. Okay, star B means like a list. You're trying to create a list, a pointer. Okay. So, yep. So A will take the value 1, C will take the value 5 and B will take all the remaining values as a list. So this is the extended tuple unpacking concept and it is only present in newer versions of Python, which is Python 3+. Now you can actually do unpacking with loops as well. So let us say there is a pairs list containing the tuples. So here the pairs list contains the first element is, this is index 0, this is index 1, this is index 2. At index 0 you have a tuple containing 1 comma A. At index 1 you have a tuple containing 2 comma B. At index 2 you have a tuple containing 3 comma C. So you can write for number comma char in pairs. Why do we write it like this? So you could have done it like this. So you can say for tuple in pairs. For tuple in pairs, you can print tuple. In this case, what will happen? So pairs list contains tuples, right? 1 comma A, 2 comma B and 3 comma C. So the variable T will first take the tuple 1 comma A. Then it will take the tuple 2 comma B. Then it will take the tuple 3 comma C. Right? And when you print T, what will happen? The tuple 1 comma A will be printed. Then the tuple 2 comma B will be printed. Then the tuple 3 comma C will be printed. This is okay. This is what we already know. Because pairs is a list which is an iterable. So it will give all its elements one by one to the variable T. But now you can do unpacking here as well. What if I want both these values in two different variables? So you can say that now you should unpack T here itself. So what we are doing? We will say for x comma y, let's say, in pairs. So now what will happen? Pairs first element is 1 comma A and you are unpacking this tuple in two variables x and y. So x will take the value 1 and y will take the value small a. So here we are unpacking inside the loop itself, in the for loop statement itself, because pairs contains tuples with two elements, and that is why I can always unpack it in two variables. So you can write it like this also and you can write the brackets also. You can write it like this as well. For x comma y in pairs. This is also okay. Print x comma y. So here x will take the first value and y will automatically take the second value in all the pairs. And you can skip these brackets as well, because unpacking and packing can happen without parentheses also. So you can skip the brackets also, then also it will work fine. But the only thing is, this list should always contain tuples with two values. If a tuple contains 3 values, then you will get an error because you will not be able to unpack it. Okay, so always remember that the number of elements should be equal to the number of variables. So this is how you can unpack inside a loop. So here we have written for number comma char in pairs. So number will always take the first value and char will always take the second value of the tuple. Okay, so firstly this tuple will be there, then this tuple and then this tuple. So when you print number and char, you will get 1 comma A, 2 and B and 3 and C. And actually we have seen this concept. We have already used this concept when we were using enumerate function. So now we know, I always told you, enumerate function gives you a pair of index comma value. So actually enumerate function always gives you a tuple. Okay, so you pass any iterable to an enumerate, it will generate another iterable with tuple of index and value. So it will always give you a tuple, not a pair. So pair inside Python language is inside, like internally it is represented using a tuple only. So that is what enumerate function does. So whenever you are using enumerate function, let's say, if I write for index comma value in enumerate and inside, let's say we have a tuple containing 1 2 3, or let's say string A, string B, string C and string D. This is a tuple containing 4 values. And if I write print index comma value, so what will happen here? This is an iterable. It will take 4 values A, B, C and D, because tuple is an iterable. You can pass any iterable to enumerate function. Enumerate function will always produce a tuple containing the index and the value. So it will produce, it is an iterable that will produce the value, which is a tuple containing 1 comma A, then a tuple containing 2 comma B, then a tuple containing 3 comma C and a tuple containing 4 comma D. And I can always unpack a tuple in 2 variables, idx and value. So this is what is happening internally. Your actually enumerate function is giving you list of tuples and you are unpacking it in 2 variables, idx and val. So here also it is a tuple. Okay, so idx is taking the first value and val is taking the second value. And when you are printing, you will get 1a, 2b, 3c and 4d in the output. Okay, so tuple unpacking and packing is used in the enumerate function as well. Now we can actually swap variables without using the temporary variable. This concept also we have seen in the initial lectures, and this is also happening because of tuple unpacking. So if I write a comma b is equal to b comma a. So firstly the first line is a comma b is equal to 5 comma 10. So internally what will happen? This is the tuple a comma b and this is the tuple 5 comma 10. So this tuple can unpack in these 2 values. So a will take the value 5 and b will take the value 10 in memory. A is a variable pointing here and b is a variable pointing here. And when you write a comma b is equal to b comma a, so here also tuple packing and unpacking will happen. It will be considered like this. So tuple b comma a is what? 10 comma 5. The value of b is 10 and a is 5. So this tuple will now unpack in a comma b. So a will now take the value 10 and b will now take the value 5. So a will now take the value 10 and b will now take the value 5. Because 5 and 10 are small integers, they will be interned, same memory location will be used. So a will now point here and b will now point here. Okay, so this is how it happens, and this is how you can swap values just using a single line a comma b is equal to b comma a. This is an application of tuple unpacking in Python. So when you print a comma b after this line, a will now have value 10 and b will now have value 5. Now let's look at the concept of tuple copying, like how you can create a copy of a tuple. So the same concepts of address assignment, shallow copy and deep copy are like the same concepts we have seen in the list lecture. So if you just watch the previous lecture, which is the list data type lecture, there we have covered the concept of list copying, shallow copy and deep copy in detail. Same concepts will apply for tuples as well. So let us see it briefly here. So if you write a is equal to the tuple containing 2 comma 4 and 3. So what will happen internally, how this will be stored? A is equal to the tuple containing, first element is a list containing 2 comma 4 and second element is the integer 3. So at index 0 we have a list and at index 1 we have an int. So internally how is it stored? List 2 comma 4 will be stored in memory address, any address, let's say 123, and no variable is pointing here. Okay, so this is the 0th element of this tuple. So this is a list, always remember the type as well. This is a list and you are creating a tuple in which the 0th element is pointing to this list. So here you will just store the address of this list and the first element at index 1. At index 1 you are storing the element 3, integer 3, and variable a will be pointing at this memory location. Let's say this is memory location 756. So internally this is how it will be stored. List will be stored somewhere else and the tuple will be stored somewhere else, and the pointer, like the pointer to the list, will be there in tuple and the variable will be pointing to the tuple. Okay. Now when you write b is equal to a, here you are not creating any sort of copy, not like shallow copy, deep copy, any type of copy. You are not creating a copy. When you write b is equal to a, it is just pointer assignment or reference assignment. So it will just assign the address of a to b. So now b as a variable will also be pointing at the same memory location. That's all. So nothing new is created. B is also pointing here. When you print B, again at the 0th index you have a list containing 2, 4. So firstly list 2, 4 and second 3 will be printed. Like, so the same tuple will be printed. And now if you do B0 dot append 5, so what will happen? B0 is this list, and when you append 5 to this, although tuples are immutable, but if it contains a mutable object inside them, they can be altered because this list is mutable. This tuple is immutable, but this list is mutable. So you can do B0 dot append 5. So this element can be added here. Now B0 dot append 5 will do this in memory, and now if you print A will print 2, 4, 5 in a list as the first element, and second element is 3. So if you change B, A will also change. Here you are not creating any sort of copy. Okay. But now if you do a shallow copy, we know that in list we have seen this. There are two ways to create a shallow copy. One is using the copy function inside list, like this. And one is using copy library. Inside the copy library there is a copy function and you can pass the list inside it. These two ways are used to create a shallow copy. Again, watch the list lecture if you have not done already. This will create shallow copy. Right? Tuples do not have a copy function at all. So tuple.copy does not exist. A tuple does not support copy function for shallow copying. So if you want to create a copy of a tuple, you have to use the copy library. You have to first import the copy library, and then you can use copy.copy, and then you can pass any tuple to it and then assign it to another variable. This will create a shallow copy. So this is not available in tuples. This is available for tuples. So now how will it work? So firstly we will import the copy library. Okay. Again, remember that dot copy function on a tuple does not exist directly. It is only applicable for list. So you cannot create a shallow copy using dot copy function on a tuple directly. That is not allowed. That is not there. So if you want to create a shallow copy, you have to use the copy library copy.copy of A. So here internally what will happen? We already know that copy function only creates a shallow copy. Shallow copy means only the outer list or the outer tuple will be copied. Inner list or inner elements are not copied. So let us see how it will happen. Firstly, we have written A is equal to tuple. First element is 2, 4. Second element is the integer 3. So in memory 2, 4 will be stored as a list. Let's say at memory location 123. Then a tuple will be created. First element will be pointing here. Second element is 3. A is pointing here. Let's say memory location 756. Now when you say B is equal to copy.copy of A, what will happen? Copy of this particular tuple. This is a tuple. This is a list. Another copy of this tuple will be created in memory. Another exactly same copy will be created of outer tuple. Just this outer tuple. Okay. So the copy of this outer tuple will be created and it will be a shallow copy. So internal list will not be copied. Still this pointer will be pointing here and the element will be copied as it is. So let us say this is at memory location 819, and when you are assigning it to variable B, B will be pointing here. And this is the concept of shallow copy, right? So if you just use the copy function, a shallow copy is created, which means outer tuple is copied, but inner list or inner tuple, if there is any, that is not copied. That reference is copied as it is. Right? So this is what happens, and this is the concept of shallow copy. So here this is what that will happen. Now if you print B, you will get the same, like the first element is 2, 4 list and the second element is 3. So this is the output. And if you do B0 dot append 5, B0 is pointing here, and if you append 5 here, so this list will be modified. And now still if you print A, then again you will get 2, 4, 5 and 3, because copy.copy created a shallow copy. And if you want to copy everything that is present, even the nested list or nested tuples, then you can use the deep copy function which is present in copy library. That is like creating a deep copy of it. So here A is equal to 2, 4, 3. So this same concept applies for list and tuples both. Okay. So A is like something like this. Okay, and when you do B is equal to A dot deep copy of copy dot deep copy of A, Then what happens? Ultimately, like whatever is present, like all the internal list, if you have more nested list also, then also everything will be copied. So another copy will be created of 2, 4. Another copy will be created of this tuple. This is a tuple. This is also a tuple. This is a list. This is also a list. And they all will be on different memory locations. And B will be pointing here. Okay, they all will have different memory locations. And now if you do B dot append, like B0 dot append 5, 5 will be appended here. And if you print A now, A is not changed. Okay, so if you have to create copy of everything, you should use deep copy. If you print B, 2, 4, 3 will be printed first. And if you do B0 dot append 5, A will not change. If you print A, still you will get 2, 4, 3, which is this tuple, okay? So the concept of shallow copy and deep copy is same as in lists. Now let's look at some examples on tuples in Python. This is the first question and it is an MSQ type question, which means multiple options can be correct. Which of the following will create a tuple with a single element? Which of the following initializations will create a tuple with a single element? So if you have to create a tuple with single element, you cannot do it like this. Because this will not create a tuple, this will just create an integer 10. Okay? If you have to create a tuple with a single element, you have to add a comma at the end, like this. So this is correct. This will create an integer, not a tuple. And you have tuple 10. Tuple 10 is okay. Right? Actually no. Tuple function requires an iterable. Right? The tuple method or the tuple constructor, the syntax is tuple and inside here you have to provide an iterable. And what you have written is tuple 10. 10 is an integer. Integer is not an iterable. So this will not create a tuple with a single element, right? You have to pass an iterable. You can write like this. Tuple and then list containing 10. But this is not an iterable. This is an integer. So this will give you an error. You cannot iterate over this element. So this is not correct. And this is correct. I told you, like if you write 10 comma. So this is like creating a tuple. This is like creating a tuple with a single element. So you can skip the parenthesis as well. You can always skip the parenthesis because of tuple packing. By default, you want to create a tuple here. Even if you skip the parenthesis, that is okay. Automatically, the compiler will add a parenthesis. So if you just write 10 comma, that is okay. It will create a tuple with a single element and assign it to the variable t. And skipping parenthesis is okay. So tuple packing will be happening here. So option B and D are correct. Option A and C are wrong. Now let's look at the next question. What is the output of the following code? X comma y is equal to 1 comma 2. Again, tuple packing is happening. X comma y is equal to 1 comma 2, which means x will have the value 1, y will have the value 2. Now you are saying x comma y is equal to y comma x plus y. X comma y is equal to y comma x plus y. So this will be taken as a tuple and this will also be taken as a tuple. So y comma x plus y is what? Y value is 2 and x plus y value is what? 1 plus 2 is 3. Right? 2 comma 3. So this 2 comma 3 tuple will unpack here. So x will take the value 2 now and y will take the value 3 now. So x and y after this line will take the values 2 and 3. So 2 comma 3 will be option A. Okay, option A is correct. Now let's look at the next question. What will be the output of this code? A is equal to 1 comma 2, B is equal to 3 comma 4, C is equal to A plus B. Print sum of C. So A is equal to 1 comma 2. So the tuple 1 comma 2 goes inside A. B is equal to 3 comma 4. So the tuple 3 comma 4 goes inside B. When you do C is equal to A plus B, if I add two tuples, what happens? Concatenation happens. The addition operator in tuples is overridden by concatenation. We have seen that. Right? Concatenation will happen. So another tuple will be created in which the elements will be 1 comma 2 comma 3 comma 4. The elements will be 1 comma 2 comma 3 comma 4. And this will be assigned to variable C. Now when you print sum of C, sum of the elements inside this tuple will be printed, which is 4 plus 3 plus 2 plus 1, which is 10. So the output will be 10. Okay. So this is what will happen here. Okay, so these were some questions and these are some hands-on exercises on tuples in Python. Again, try to solve them on your own first. Like try to write the programs for these particular problems on your own. We will see some of them in the demo which is coming next. In the demo, we will see how tuples are created and all the operations that we have seen. And we will also solve the exercises which are mentioned here. Before going to the demo, try to solve these problems on your own. So in this lecture, we saw tuples, like what tuples are, the data type, and what are the different operations and important methods which are available on tuple. Very important concept coming to exams is tuple packing and unpacking. And we have seen some examples on that as well. So now let's look at the demo on tuples in Python. Okay, now let's see a demo on tuples in Python. So let's start with creating tuples. So just like list, in list we use square brackets, and tuples we use round brackets. So we can create an empty tuple first. So if I want to create an empty tuple, I can just write empty round brackets and it will create an empty tuple for me. So if I now print this empty tuple, and let's say I print the length of this empty tuple, and also let's print the type of this empty tuple just to see. Here empty tuple, like you don't need to name it empty tuple for it to be a tuple, right? It's just a variable name. I can name it anything. So yeah, it is an empty tuple. Like when I printed it, it's this length is 0 and class tuple means it is a tuple. Now if I want to create a tuple with a single element, can I do this? Let's say if I add a single element, if I print element now, and if I print the type of this element, what will happen? If you have to create a tuple with a single element, you cannot do it like this. You have to add a comma, because this will, like here, if you just write this, it will just create an integer, because like bracket 5 is nothing. It is trying to evaluate an expression with brackets in it, right? So it will just create an integer, not a tuple. So you have to add a comma, then only you can create a tuple. It should contain at least one comma if you're entering a one element. If you're entering more than one element, then it's okay. You don't need to add a comma at the end. So just to be sure, like even when you print the tuple, it prints it like this, because it is a tuple with one element. If you print the length of this tuple now, it will be a tuple containing a single element. Okay, so length will be 1. Now you can have multiple element as well. So if I create a tuple, let's say containing a number, like let's say 3, 4 numbers, we can do that. If I print p, and it will be a tuple containing 4 elements. And even a tuple can have multiple different type of elements as well. Let's say one integer, one floating point number, and then one boolean value, and it can have a string as well, and it can have a list as well. You can have this. So this tuple basically contains different types of objects, and total there are 5 different objects present inside this tuple. So if I print the tuple, and if I print the, let's say, the length of this tuple, length will be 5, because there are 5 different objects, 1, 2, 3, 4, and this list is another element, which is 5. So this is how you can create tuples using round brackets. And now you can use the tuple constructor to create tuples as well. Just like list, we can use the constructor for tuples as well. So if you have to create an empty tuple again, let's say empty tuple now, so you can use the tuple, and if you don't pass anything, it will create an empty tuple. So again, if you print this, it will be an empty tuple. Okay, and if you want to create a tuple containing a single element using this logic, you can just give it you can give it any iterator. So list is an iterator, so you can convert a list into a tuple like this. Let's say it contains a single element. So if I print t now, it will be a tuple containing a single element 1. And similarly, I can give it multiple objects as well. Let's say I give it multiple objects like this, 1, 2, 3, then it will create a tuple for me. And I can give any iterator. Basically, I can give it let's say a range function. Range function is an iterator, we know that. So range function, let's say range 1 to 10. So it will add all the elements inside this iterator in a tuple and give it that to me. And tuples are ordered as well, so the same order will be there. And I can even create one using strings, because strings are also iterators. So this is also how I can do it. Okay, so this is how you can use the tuple constructor to create tuples. Now let's look at indexing and slicing of tuples. So first is accessing elements. Tuples are immutable in nature, but you can still access their elements. So if I create a tuple, just like strings or list, you can access elements of a tuple as well. Indexing works the same way. Positive indices go from 0 to length -1, negative indices go from -1 to minus of length. So if I print t of 0, I'll get an element t of 1, 2, 3, and even -1, -2, -3, -4, and no other indices are allowed. Okay, so let's print all of them: -4, -3, -2, then -1, then 0, 1, 2, and 3. Okay, So at 0, the 0th element is 1, then the first element is 2, then 3 and 4, and then like you will get in reverse order 4, 3, 2, 1, because -1 is the last element, then -2, -3 and -4. So this is how you can access elements in tuple. But again, tuples are immutable. You cannot, once created, just like strings, you cannot change the elements in place. So if you try to do t of 1 is equal to 5, you cannot do that. You cannot change an element. So if I just try to do that, it will give me an error because we have created a tuple of size 3 and tuple object does not support item assignment. Just like string, you get the same error. They are immutable. Lists were mutable. There we could have there we have done this and it was allowed. Okay, but interesting thing is if a tuple contains a mutable object, that can be changed. So if a tuple, let's say, contains a list and then the second element is an integer, the first element 0 is actually t of 0 is the list, so that can be changed. T of 0 can be changed. So let's say if I do t of 0 1 is equal to 100. So what does this mean? T of 0 is this list, and inside this list the first element is the index 1, which is this element 2. That can be changed to 100. This is allowed. If I print t now, this is completely allowed, and this element is now changed to 100. You can even append, insert, whatever you want to do, you can do this to this list, because this is a mutable object. And it is the same thing other way around as well. If a tuple is present inside a list, you cannot change that tuple or strings. So immutable objects cannot be changed once created. Cool. So this was about immutability. Next is slicing tuples. So slicing works exactly the same way as we saw in strings and lists. So let's create a tuple 1, 2, 3, 4, 5, and slicing always creates a new copy. Okay. So if I print t of let's say 0 to 3. So starting point is 0, ending point is 3. So and ending point is not included. So we will stop at index number 2. So 1, 2 and 3 will be printed. Similarly, the default value of start is 0. Even if you don't write it, that is fine. And similarly the default value of ending point is the length of the tuple. So here a tuple is created like 4, 5, because we started at index 3 and we took all the way till the end. And if you do step size, if you give step size as well, it will take alternate elements, and if you give step size as -1, it will take elements from the back. So this is a standard way of reversing a tuple. Again, the original tuple is untouched. You always create a new copy whenever you are doing a slicing. And anyways, like, original tuple has to be untouched because tuples are immutable in nature, so you cannot change them anyway. So this is how you can create slices of tuples as well. And this concept actually will come in like actually we have seen all like accessing elements, slicing. These concepts are essentially same for all collections. So we'll keep seeing them. Okay, now let's see how can we loop through tuples. Again, we can use a for loop or a while loop if you want to loop through a tuple. Let's say a tuple contains strings A, B, C and D. And if I want to loop over all the elements of this tuple, what I can do is for because tuple is also an iterable, I can just say for item in tuple print item. Okay, so it will print all the elements of this tuple one by one. Okay, so the name of the tuple was T, so we can do this. Okay, and we can use a while loop as well, but for while loop we will need a counter just to track like at which index we are at. So while I is less than the length of tuple T, the same as we did it in strings or lists, we can just print T of I, and don't forget to increment I after that. And this is also how you can do that. So these are some ways of iterating through tuples. And if you want the index as well inside the inside the loop, you can just say for index comma item in enumerate of T. And now we know that an enumerate function gives a tuple as output, and this tuple actually unpacks in this tuple, which means index takes the index and item takes the value. So we can print the index and the item here, and you will get the index and item both. Now let's look at some operations on tuples. First we will see mathematical operations. So just like strings or lists, you can add two tuples as well. So if I just directly print the tuple 1, 2, 3 plus the tuple, let's say 4 or 5, I'll get a tuple containing all the elements of these two tuples. Again, this is not in place. Another tuple is created, and like these two tuples are kept as it is. And we can multiply a number with a tuple as well, again in the front or in the back or wherever you like, and it will just repeat the same elements that many times. And we can use the in operator inside the tuple. So I can say 3 in 1 2 3. It will just check that this particular element exists inside the tuple or not. And similarly, you can use not in as well. Not in is the opposite of in operator. And length, we have seen many times. Length operator just tells us how many elements are present inside the tuple. And okay, here in the length function I have not given a tuple, so we have to create a tuple first. Okay, so it says that the length of this tuple is 3, and you can use the other mathematical operations, just whichever were there in for list, which means min, max and sum. So if you want to find the minimum of the tuple 1 comma 2 comma 3, you can do that, and you can get the maximum as well, as long as they are comparable. So you can have all strings as well if you want. Let's say A, C and B. It will give me the maximum as C, because strings are comparable in lexicographical order. And we can print the sum of elements as well. So if I give inside the sum function, if I give elements or a tuple, it will give me a sum of all the elements in that tuple. So these are all the mathematical operations that we saw for list, and they are all applicable as it is for tuples as well. Now if you want to search or count, again same functions are there, index function and count function. So if you have a tuple containing a few elements 1 2 1 3 2, and if you want to find the index of any element the first time it appears, so if you do index function, it will just give you where this particular element occurs for the first time, and it will give you the index, and it gives error if the element is not present. So be aware, if you are giving it an element which is not present, it will give you an error. So always be sure first. And for the same tuple, if you want to find how many times an element is present, you can use the count function. So if I do t dot count of 2, it will give me just how many times that particular element was present inside this tuple. Sorting tuples. So tuples cannot be sorted in place, because tuples because tuples are immutable. So dot sort function like list is not available. If you have to sort a tuple, you have to use the sorted function instead. So let's say this is your tuple, okay, and if you want to sort it, you can use the sorted function. Sorted of t will give you a list containing all the elements in a sorted way. It will give you a list. So let's say you want to convert it into a tuple only. So if you just write, like, let's say the variable name is sorted tuple. So sorted tuple will be a tuple, it will not be a tuple, it will be a list right now. So if I print it, it will be a list, right? So if you have to convert it into a tuple, again any iterator can be converted into a tuple using a constructor, right? So you can use the tuple constructor to convert this list into a tuple, and this is how you can get the sorted tuple out of it. So this is how you can sort tuples. Again, dot sort function, which is in place sorting, is not allowed because tuples are immutable. Now let's move to tuple copying. If you want to copy a tuple, again, like there is a concept like the concept of shallow copy and deep copy. Let's use the same example that we discussed in class. Let's say you have a list, the first element of a tuple is a list, and the second element of the tuple is an integer. So here we have a list containing 2 comma 4 and an integer 3. If I just write b is equal to a, this is not even copying, this is just address assignment. So if I just do, let's say, b of 0 dot append b of 0 dot append, let's say 5, because that is a list and I appended 5 to it. And even let's say I do b dot append, actually I cannot do b dot append because lists are tuples are immutable. So that's all I can do, right? So if I do this, it is address copying. If I print a and b, both a and b will be changed, right? And you can verify it. You can print the ID of a and b and see that they are both pointing to the same memory location. And that is why this happened. And even if you do something like this, so let's say if I do like, I'll give you one more beautiful example. Here a and b both are pointing to the same memory location. Let's say if I do b plus equal to a tuple containing 6, what does this mean? This essentially means b is equal to b plus a tuple containing 6. So this is also allowed, which means 6 will be added at the end of it. I cannot do this, but like what will happen here? this new list, this new tuple that is created. Now let's print the ID of B first. Sorry, okay, this is not a tuple, this is an integer, right? So let's create a tuple. Okay, so if I do this, anything of this sort, now it points to a new memory address, because like what happens is when you do b is equal to b plus 6, you think that you added another tuple at the end of this tuple, but again, tuples are immutable in nature. So this b was previously present at this memory address, and when you added this particular elements of this tuple inside this tuple, a new tuple is created at this memory address. And now hence now when you do b is equal to b plus 6, now this b variable is now pointing to this memory location, not the old memory location, and hence the original a will remain unchanged, like a will not change, but b actually changed. If you print b, there you will see 6 added. Actually 6 was added 3 times because I ran this cell 3 times, but I hope you got the idea. A is unchanged. So you cannot say that this is an example in which like you can see that this is a deep copy or something. No, but like when you did b equal to a, they were pointing to the same memory location. When you did this thing, now b was pointing to some other memory location, and that's why like but yeah, be aware here when you made changes to b of 0, then changes happened in a as well. Okay, now how do you make a copy of a tuple then? Like this is not allowed. So how do you make a copy of a tuple? You can use the copy function from the copy library, because dot copy is not available in tuples. So we can use the copy function in copy library, or you can use slicing. So if I import copy and let's say I write the same piece of code, and if I create a shallow copy, copy dot copy of a, and if I print do the same thing, copy dot copy function creates a shallow copy, and hence changes in a are reflected in changes in b are reflected in a as well, right? And like you can see this thing here, right? And but instead, if you don't want this to happen, you can use copy dot deep copy of a. So if instead of copy dot copy, if you use copy dot deep copy of a, now they will be pointing to other like different memory addresses. They are now pointing to different memory address, and even the list which are contained inside them are now pointing to different memory addresses, and hence when you changed b, a did not change. So the ideal way, if you have nested structures, whenever you have nested collection, list inside a list, or a tuple inside a list, or a list inside a tuple, things like that, always use deep copy to avoid mistakes. Now let's look at the concept of tuple packing and unpacking. We know that in tuples we don't require round brackets always. Even if you write comma separated values, they will be considered as tuples. If I write t is equal to 1, 2, 3, automatically it will take it as tuple only. So if I print t, or if I print the type of t, and even if I print the length of t, it will be actually considered as a tuple only. Okay, so 1, 2, 3 class tuple, and 3 is printed as the output, so you don't need to add brackets. So this is what tuple packing is. And now unpacking is what? You can even unpack this tuple. So this t is now a tuple containing 1, 2, 3. You can unpack it in inside variables without adding brackets. I can say a comma b comma c is equal to t. You can add bracket here as well if you want, but even if you don't add brackets, this will be now again considered as a tuple. So this tuple will unpack in this tuple, and this is allowed. You can add variables on the left hand side. So if you print a and b and c now, the values of a, b and c are printed as 1, 2 and 3. So this is allowed. But be aware, mismatch can happen. Like if you give just 2 variables, then this is not allowed. It will give you an error, too many values to unpack. So there are 3 values here, and here there are only 2 values here, so you cannot unpack it like this. For this type of feature, there is extended tuple unpacking given, so you can give a star. So let's say there is a tuple containing values 1, 2, 3, 4, 5. And you want to unpack the first value in A, you want to unpack the second value in B, and you want to unpack all the other values in C. You don't know how many values are there, so you can write it like star C. So this can happen. And now if you print A, B and C, the values of A, B and C, A will be the first value, B will be the second value, and C will be the list containing all the remaining values which were there in the tuple. So this is what extended tuple unpacking is. And we have seen this thing already before. Because of tuple packing and unpacking, we can actually swap 2 variables as well. So if we have A is equal to 5 and B is equal to 6, And if I write a comma b is equal to b comma a, actually here tuple packing happens, here also tuple packing happens, and now this tuple unpacks inside this tuple, and hence a will take the value of b and b will take the value of a. So if I print the values of a and b after this operation, they will be 6 and 5 now. Okay, so this is how swapping of values happens. So this was all about the tuple concepts that we saw in class. Now let's look at the practice exercises. Again, we have some problems as homework and some in classwork. So, and also always try all the problems on your own first. Only if you're not able to see the get the solution on your own, then see the solution. For homework problems, I'll give you the code at the end. There you will find the solution, and they are pretty simple. Access the last 3 elements of a tuple using slicing. We know how to do that. You can use negative indices as well for slicing. That will be very easy in this case. Concatenate 2 tuples and print the result without plus operator. So without the plus operator, how can you concatenate 2 tuples? Think about it. Then let's look at the next question. Given T is equal to a tuple containing an element or another tuple. You might have an element or another tuple inside it. You have to print the number of flattened elements inside it. Flattened means if you flatten this entire tuple, which means if you remove the inner tuples which are present, like 2, 3, 4, 5, like that. So the total number of elements will then be 1, 2, 3, 4, 5. So you have to print that. So how do you flatten a tuple? In tuples we don't have comprehension, just like in list. In list we can do list comprehension and flatten a list and then print the length of it. But here we don't have comprehension, so we have to use loops. We will have to use a loop and then see every element inside it. So let's create a tuple first. Let's create the same tuple that is given in the question. And for now I am assuming the depth of this tuple is at max 1, which means there can only be one tuple inside a tuple. There will be not another tuple inside that tuple. I am assuming that problem will be a homework for you. Because in that problem you will use another loop. So you try to do that. So now let's create a flat tuple. Let's directly count how many elements we have. Okay. So let's say initially the number of elements in the flattened tuple is 0. Now what I'll do is I'll iterate over all the elements inside the tuple for item in T. What I want to do is, if the element is itself a tuple, I will go again inside it. But if the element is not a tuple, I'll just directly increment the count by 1. So what I'll do is, if the type of item is equal to class tuple, which means it is of type tuple. So I can what can I compare it with? I can create another tuple and compare it with that. What I am trying to say is I can say type of tuple. This is an empty tuple, right? Because the type of empty tuple will also be a tuple. So if the type of item is equal to the type of an empty tuple, which means they are both tuples, then I want to go inside. Or you can write the tuple constructor here, right? So if the type of item is equal to the type of tuple, which means they are both of type tuple. And to write this statement, there is another way as well. You can use the isInstance function. You can use the isInstance function as well. IsInstance function I have not given in class because that is it's very superficial. It's not very important for exam, but yeah, you should know that. So in isInstance function also you can say that if T is of type tuple, then here they are given if T is of type tuple, then it will give you true or false. So but yeah, even this statement is fine. You can say that if item is of type tuple, essentially you again want to go inside it and see how many elements are there. Or you can directly say that you can increment the count by length of this item, right? Because the length of this item is what? It will give you how many elements are present inside there. So if the item is of type tuple, you want to increment the count by the number of elements present inside the tuple. Otherwise, you just need to increment the count by 1 because it is a single item. So at the end, now you can print the count of the number of elements, which is 5 here. Or even you can have, let's say, another tuple which contains some more elements, 6, 7, 8, 9. So now you will have 9 elements. You can solve this problem like this, and again a homework problem here will be, what if there can be multiple tuples inside a tuple? It can be any number. So what will you do? Again, hint is you have to use loops. Specifically you will have to use while loop to solve that problem. So think about that problem. Cool. Let's look at the next question. Given a tuple marks, you will be given marks like this, which will be again a tuple of tuples. where each inner tuple represents midterm marks and final marks. Calculate the average marks for each student. So you just need, inside this tuple there will be various tuples. You just need to calculate the average of both the values present inside them and print it for every student. So let's take a for loop for student marks. Student marks is a tuple in marks. So for any particular student, the marks is given in student marks. So student marks will be a tuple. If you want to verify, if I print student marks, you will get the tuple, this tuple, this tuple, and this tuple. Now you just want to calculate the average of it. So average will be what? Average will be the sum of these elements upon the length of the tuple, right? So I can just directly say that sum of student marks upon the length of student marks. Okay, this will give me the average of every student. So for 80 and 90, the average was 85. For 78 and 88, the average was 83 and 88.5. So this is how you can calculate the average of every student. So this was the solution to fourth problem, and fifth problem is given a tuple, write a program to compress consecutive duplicates. So if you have 1, 1, 2, 2, 3, 3, 3, 4, 4 consecutive elements, if they are same, you want to compress it into a single value, like this should be becoming 1, 2, 3, 4. Again, this can be very easily done using a for loop. You just need to compare this value with the previous value. And again, I'll give you the solution if you're not able to do it, but firstly try this on your own. So these were some of the practice exercises that we saw in class, and this was a demo on tuples, everything that we saw on tuples. Thank you so much for watching the lecture, and let's meet in the next lecture. Bye bye.